Welcome to Khetz Tutorials, and in this video I'll be talking about Venn diagrams. Now these are graphical representations of a sample space. So you expect some sort of figure which shows a certain sample space. But then what is a sample space? Now from the name you can see that we're talking about sample, which is a portion of something. So usually we talk about a portion or a part of a total population. For example, if I were to come to your class and conduct a survey, a certain question, which can be anything, to you guys, then I have basically restricted myself to just you guys. The answers that you give me basically don't represent the whole population. Those are just answers which apply to you. So that is a portion, that is a sample of the whole population. And that is what is meant by a sample space, a small group or a small portion of something which is larger than it, basically. So that is a sample space. And since we're only sampling, then we basically expect to have a total. So in Venn diagrams, the sample space, or everything which consists or which is part of the sample, will be in a box. Then you basically have circles which represent classes, and these circles can intersect or they can be by themselves, separate circles like that. And numbers or probabilities, so you can have numbers or you can have probabilities in here. So if you have probabilities, you expect to have that, and your probabilities should sum up to 1. And if you ever have numbers, then that should sum up to the total of your sample space. So let's say your class consists of 25 people. Now expect all the numbers which are in here to add up to 25. And you might find that someone in your class does not necessarily fall into any of these, A, B, C, or D. And that person would basically fall outside the classes. But the person is part of the sample space. That is why we basically keep them inside the box. So you have a sample space denoted or shown by the box. Then you have classes which you can further divide the people or the samples, right? And anyone or anything which does not fall in any of these classes is basically written outside of the classes. So that is a brief overview of what Venn diagrams are, how you use them, and how they basically represent information. And I just can't think of any other way to basically show how these work than to do an example. So let's do an example. I'm going to move on to the next page where I have my example ready. So this is the example that I have. And you might find that you basically have your Venn diagram given to you, or you might have to construct that yourself. So in this video, I just focus on this type of example where you have the Venn diagram given to you. And in the next video, I'll just make that video all about an example where I basically cover how to construct a Venn diagram from given information. So let's focus on what we have in front of us. Now, here's what we have, and we are given some information down here, as well as the Venn diagram which is associated with the information. So we're told that a sample of 60 people is asked. So this is where I'm reading down here. A sample of 60 people is asked which of 3 sports they watch on TV. The sports are rugby, and rugby is shown as R. So now this symbol above this circle basically shows that everyone who watches rugby falls into that portion of the sample space. So everyone who watches rugby should find themselves in here. And the numbers which are given are the number of people who actually do watch rugby. And now one other thing which I didn't mention is that when you have intersections, now this portion represents the intersection or the people who specifically watch rugby, and S in this case is soccer. So this portion by itself represents the intersection of people who watch rugby and soccer. But this one here, which covers all three circles, or which is the intersection of all three circles, covers all the people who watch rugby, soccer, and C, which is cricket. And now all these numbers that go in here, as I previously said, are associated with the people who actually watch these sports. And if you look on the outside of cricket, soccer, and rugby, you actually do have 15 people who don't watch any of these. So if you have a number outside, basically means it does not fall in any of the classes here. So these people don't watch rugby, soccer, or cricket. So this is the given Venn diagram, and some questions are basically asked, and the questions are obviously associated with the Venn diagram. So here's what we have, and let's go right into the questions. So before we go into the questions, you can always ask yourself, when given a Venn diagram or when you want to solve these kind of problems, the probabilities, if you're not directly given the probabilities in here, the probability would just be the sum of a territory divided by the total of the sample space. Total of sample space. So in this case, we have 60 people, so expect the total of the sample space to be 60. And now the sum of the territory will depend on the conditions that we want to find. For example, if we asked for the probability of people who watch rugby only, then you'd forget everything else which is outside the rugby circle. But we can't include these parts because we're specifically told those who watch rugby only. So we only talk about this portion, which is just 8. So 8 is the only one there, so we don't have to add anything to it. And we divide that by 60, for example. And that is the probability of taking someone who only watches rugby, right? So this term is very important. If the question doesn't say only, then even if we have someone who watches rugby and soccer as well as cricket, they basically do watch rugby. Even though the other sports are included in that definition, if this term only is not there, then we'd basically include that. And you'll see this in the questions as I go through the questions. So now just keep this in mind, that we are talking about the sum of a territory, or the sum of the people who fall under certain sections. So we'll always be looking at a section and we'll forget the rest, then divide that section by the total of the sample space. So let's go right into the questions. I just keep this here so that we keep referring to it. So the first question says, what is the probability? Find the probability that a randomly selected person watches none of the sports. So the sports are rugby, soccer, and cricket. So they fall in this territory. But now we are looking at everything which is outside that territory. So the territory that we're looking at is on the outside. So everything on the outside. And on the outside, we only have 15, which should be our answer. But since we asked for the probability, 1.1, we're going to say 15 is the sum of all the values which are in the territory where none of the sports are watched. Then we're going to divide that 15 by the sum of, or the total of the sample space, which is 60. And the question asked us to write this fraction, or all our fractions, in the simplest form. And if you simplify this, you should get 1/4. So that is the first question. Moving on to the second question. So what is the probability that a randomly selected person watches soccer? Now please note that the word only is not there. So as long as a person watches soccer, we basically can take them. Even if the person watches something else, but as long as they watch soccer, we basically include that portion. So the soccer bubble or circle is over here. So that is the territory that we're talking about. And as I said, we don't care about these ones. We actually do include them because it didn't say the probability that the person watches soccer only. If it said that the person watch soccer only, we'd only consider this part, which does not intersect with anything else. But now that it just said watches soccer, then we include all these people, right? Let's include all these people in here. And what you have to do is just sum everyone who is in there. And doing so, you're just going to have the sum of everything which falls inside the S circle. And the sum of that is, starting with the 4, you have 4, you have 2, then there's 1, so 4, 2, 1, and 16. Those are the ones that we actually add up, 4, 2, 1, and 16. Then divide by the total of the sample space. So this is 6 added to 16 is 22, plus 1, 23. Divided by 60, and that is your answer. We can't simplify this further, so that is that. Now moving on to the next question. Once again, you're just going to say the sum of the territory divided by the total of the sample space. So the next question says the probability that someone watches rugby and soccer. And once again, there's no point in this phrase where it said only. So even if the person watches rugby, soccer, and cricket, then we do take that as well. So, but now our focus is on this section where the person watches rugby and soccer. So let's look at that. So the R circle is over here for rugby, and the S circle is over here for soccer. We're interested in the intersection of these two, and these two intersect here, where we have people who only watch rugby and soccer. So that is the portion where people only watch rugby and soccer. But here we have people who watch rugby, soccer, and cricket. But within that portion as well, those people do watch rugby and soccer. So we include these two because the question didn't say that we only have to focus on the people who only watch rugby and soccer. So we include this other intersection, which includes people who watch rugby, soccer, and cricket as well. I'll say this over and over again. Always look out for this term only. We weren't told to look for people who watch rugby and soccer only. Otherwise, we would have gone for this portion only, that intersection only. So include both of these, and we're therefore going to have 4 plus 2 divided by the total of the sample space, which is 6 over 60. Simplified, we have 1 over 10. So now we move on to the next question. I think we can now erase this just so we create some space. Let's erase this. Moving on to 1.4, let's look at 1.4. So 1.4 says, let's see what it says down here. The probability that a randomly selected person watches cricket or soccer, right? So now we are trying to land ourselves, or trying to find ourselves in either cricket or soccer. So that is the territory that we're talking about. So what is the probability that you fall in this territory, right? And once again, there's nothing that specifies that we are only focusing on certain sections. They just basically said cricket or soccer. So anywhere in these two circles. So to do that, you basically add everything in those two circles, C and S. So doing so, this is what you have. You have, starting at the top, 4 plus 16 plus 2 plus 1 plus 3 plus 11. And these are the numbers which are in the territory C and S. And divide that by 60. At the top, you have 20 plus 2, which is 22, 23, then 26. Added to 11, that is 37, divided by 60. So that is the answer to that. You can't simplify this further. Moving on to 1.5, let's look at 1.5. 1.5 says, what is the probability that a randomly selected person does not watch cricket? Okay. So now we're excluding the cricket territory, which means everything in here is excluded in our calculation. So we don't want this part, which means we're now talking about this portion. Everything else doesn't necessarily have to be in the circles. even on the outside, we include everything on the outside because everything on the outside also forms part of the territory which is not cricket. So you can view this as being not cricket. So which portions are not cricket? So basically everything except the cricket portion. So to find that value, once again, we just add up the values of the territory that we're talking about. And that would be, starting on the left, that would be 8, added to 4, added to 16, and then adding the value which is on the outside. So this is the territory that we're interested in. Have that, and we also have that over there. So 8, 4, and 16. And that would be 20, that would be 28. And the rest would make 43. So divided by 60, once again, the answer is 43. So you'd always look at a particular territory and you'd always exclude everything else which is not part of that territory. And once again, you can't simplify this, so that is the answer. Moving on to 1.6. 1.6 says, what is the probability that a randomly selected person watches rugby but does not watch cricket? So let's see. So they have to watch rugby, they have to be somewhere in the R, but we have to exclude everything that has to do with cricket. So we're going to exclude that portion that has something to do with cricket because the cricket circle is over here. So you're going to skip that and only focus on that. So it doesn't say anything about soccer. It doesn't say anything about soccer. So it's fine if the person watches rugby and soccer, but the only constraint is that they shouldn't watch cricket, right? So include everything which is in the R circle. That does not include C. So that would be the intersection of R and C. That would be the intersection of R, S, and C. So we exclude that because it includes the C. And we only focus on the part that has R related with it, but not C. So doing that, then we only have 8 and 4 to worry about, which are on that side over there. So now the answer would consist of you adding 8 and 4, and the total of that should be 12. And in simplified form, that should be 1/5. Now moving on to 1.7, it says find the probability that a randomly selected person watches neither rugby nor cricket. So now we're talking about the territory which is outside R and C. So everything associated with R and C should be excluded, basically. So R is over there, C is over there. Everything that they cover should be excluded because we're looking for people who don't watch rugby or cricket. So now the people who do watch actually fall in here, and everyone on the outside does not watch rugby or cricket, right? So that is how you'd compute that value. And looking at that, since R and C are over there, we're only looking at 16 and 15 because those people don't watch rugby or cricket. And you just add those two up, and the final value should be 31/60. And you can't simplify this, and that is how you basically answer these types of questions. So if you're given a Venn diagram and you're asked to find probabilities, you'd always have to sum a certain territory and then divide it by the sum or the total of the sample space. And if you try to add all of these values in here and they don't seem to add up to your sum of the sample space, then that probably means that you basically have a value which is missing. If you add all of these values or all these numbers in here, then you should get 60. Now let's say, for example, you were given a question and now there was a missing number, then you'd have to find that missing number. So everything over here should add up to 45, and you'd maybe find that you're asked to find the number which is missing, and that would be 15 on the outside. But in this case, everything was given to us and we just had to answer the questions. The way that you answer these types of questions, just sum the territory, divide by the sum of the sample space. So once again, I will look at another example where you have to draw your own Venn diagram where you have to do it by yourself from scratch, and that'll be the next video. I hope you found this video helpful. If you like it, just give it a thumbs up, and I will see you in the next video.